Hi there guys, in this video we're going to look at a new way of measuring angles and that's called radians. Now before we get into that we're going to stay with degrees a little bit and just talk about some coincidences maybe. So have you ever thought, well, why does a circle have 360 degrees? Did we make it up? Yeah, we did. And is it a coincidence that there are 360 degrees in a circle and 365 days in a year? Well, if you actually look into the calendar and the history, it's had all sorts of number of days in a year. And thanks to the Romans, we've now got this, it's called a Gregorian calendar after Pope Gregorius. And that's why we have that. But 365, that's not a great number for like splitting up into like say quarter turns, half turns. So they're linked. Maybe if we're Martians, I could be wrong here. I believe Martians have a 680 days orbit of the sun. So maybe they would have 680 degrees to their circles. Who knows? But what we're going to do is look at a measure called radians. So you have to have a bit of an open mind. A lot of people are like, well, we're just doing all of these things that I can already do in degrees, so why bother? One, it's easier, okay? And two, it's on your syllabus, so get used to it. But I promise you that first fact, lots of things are much, much easier in radians. So let's have a look at a quick PowerPoint that I made to try and explain what a radian is. So if you take a circle, and let's draw a radius. We'll take that exact same length, we're going to spin it 90 degrees, kind of make a line segment tangent thing. Okay, so let's imagine this bit at the bottom here is fixed. We're going to apply a force at the top and we're going to bend it around the circle. So the length won't change, it's just going to be really tight to the circle, something like that. So that is also length of the radius. It's not a radius, we can't obviously call it a radius, it's on an arc. A radius is a line from the center to the circumference, but it's the same length. But that third line I just drew is a radius. And so we have this, this sector of all the same equal length. And the angle in between them is what we call a radian. And we can write 1 radian or 1 rad. Sometimes, less often these days, you see the C symbol, which is, I just think of it as a degree symbol with a bit rubbed out. That's how they must have come up with that, because what's a C got to do with radian? It's just a nice quick way of writing it and distinguishing between the two. So circumference, you should know as a formula, is 2 pi r. Pi d is what is most common used these days. When I was a kid, it was all 2 pi r. And it's useful, this one, because it links to radians really nicely. So the whole circumference is 2 pi times the radius, right? That's what that formula says. So we need 2 pi radiuses to go all the way around, and all the way around is 360 degrees. So that means the number of arcs that are needed there are 2 pi. Well, that's a difficult number to deal with because it's irrational. But roughly, we could say it's 2.314, which is roughly 6.28 arcs all the way around. And I've got a nice visual to show you that. So there's 2, 3, 4, 5. And you can see 6 doesn't quite get all the way around. So this little gap here is going to compensate for that little bit there. But that's really inaccurate, isn't it? Because we've rounded to 2dp. So it's rubbish. We've got a lovely exact answer just above as 2 pi. So we know full rotation in a circle is 360 degrees. And we also know that full rotation is 2 pi radians. Okay, so we can say that 2 pi radians is equal to 360 degrees. Simple as that. And if we divide that by 2 pi to both sides, you can see that 1 radian is equal to 360 divided by 2 pi. So you're going to have to use that to convert between them. It's not something you often do because you're either working in radians or in degrees, but it's a skill that you should possess. Let's have a look at the graph. So a sine graph, that should be really familiar to you now. Instead of 360, what you need to get in the habit of doing now is writing 2 pi. Instead of 180, pi, half pi, and 1.5 pi, 3 pi over 2. Okay, so get in the habit of using those. And I will say while we're here, we're not going to do that this lesson, but on your setup, so shift setup is the same button as the menu at the top. you can change it to your angle unit to radians. Just be really fluent switching between the two. Now, there's a little glimpse. It is much easier with radians. Okay, so let's go back to this. So we need to be able to convert between degrees and radians. Okay, so we know that 1 pi radian is equal to 180 degrees. So on the left here, I've got pi divided by 20. Well, this is in radians because any mention of pi means we're dealing with radians. So I'm going to put that little c there. So you can see that from using this fact, this side has been divided by 20. So we're just going to do exactly the same, which equals 9 degrees. That was easy. This one's a little bit harder to get your head around, but what I would suggest, if we know pi radians is equal to 180 degrees, well, if we divide both sides by pi, we're going to get 1 radian. Now, to get to 0.46, it might be really obvious to some of you, but lots of people watching it, they find this bit a bit weird. But if you wanted to find what 2 radians is, you would just times that by 2, right? If you wanted to find what half a radian is, you would just half that, times it by half. So if you want to find what 0.46 is, so is 180 over pi, we're just going to times it by 6. So that would be your conversion that you needed to do. Let me just type that in quickly. So 180 divided by pi times 0.46, and you get 26.356, and obviously it goes on forever and ever and ever. But that is a measure in degrees. Like I said, we don't often do this. So 8 degrees, so let's go for 180 degrees is equal to pi radians. Let's find 1 degree. So that's going to be pi over 180. And then 8 degrees is going to be that times 8. So it's a skill you can practice in the first chapter of your book, but it's nothing to, you're not going to use it that much. But this is far more important, and what we're talking about here is, and you can see this all written in your book, but you don't have to memorize it. There are some things that we are going to ask you to memorize, but this isn't one of them. But this first one you should have seen before, and now I'm going to write it down here. So if I said, what is sine 30 equal to, hopefully you know that is the same as 150 because of the symmetry of the graphs. If that was 30, that is 150, and both of those equal a half. Okay, so this one is saying sine theta is equal to sine 180 minus theta. Okay, those are identical. Now, instead of 180, we're going to go into radians and just put a pi there. So that's it. So this one is the same as sine theta. But you don't have to know all of that. You don't have to really understand symmetry. You just have to understand your cast diagram. So if we think about where is this? So sine pi minus theta. Well, if this is naught, this is pi, and this is also 2 pi. So pi take away an acute angle would be here. And you know that all values of sine here are positive. Okay? So this is the only bit I want you to understand is what this is equivalent to. And you can see that here. So sine theta is equal to sine pi minus theta. That's what I've written there. So it's basically a nice easy way to get symmetry across. Let's have a look at sine pi plus theta. Well, now we're adding something to theta. So we're going past theta, past pi, sorry, and we're going past the 180 if you want to think about it in degrees. So we're actually going into this quadrant here. And what do we know about sine values? Well, they're negative because only tan values are positive. So this is equal to that. 2 pi minus theta, well, that's going to take us into this last quadrant. And also in this quadrant, it would be equal to minus sine theta because only cosine of angles are positive over here. So I'm not going to draw the lines on, but we're just going to point. So this first one, we're looking at this quadrant. What do we know about cosine values here? They are going to be negative. Okay, so obviously we're losing this just like we did here. We're writing in a simpler way, just using the symmetry. But we're not thinking of the graphs, we're just using our cast diagrams. Chi plus theta takes us into this quadrant. What do we know about cosine values there? Well, they're negative as well. Cosine, we're taking theta away from 2 pi, so a full rotation. So we're just in this area here. All the cosine values are positive. That would be the same as that. Tan, let's go back to this quadrant here. We're not doing this one, obviously, because that's just tan theta, yeah? And sine theta and cos theta, and they're all positive. So theta, so we're up here, so only sine's positive, so this would be equal to minus tan theta. Down here, it's tan theta. And this last one here, tan values would be negative. So that's going to make a little bit more sense when we start doing questions like this. So in your book, actually, it's on page 115. Just write that down here. There is a list of, oh no, it's not that page. It's 117, scratch that. You've got a list of exact values. You need to learn them, but at this point, it's not the end of the world. Just keep that page open or keep flicking back to it when you need to answer these questions. So, what is the exact value of this? So we're trying to use our symmetry knowledge to find an equivalent of sine 2/3 of pi. Well, if we go along our cast diagram, we get to half pi, and then we get to full pi, but 2/3 of pi is in here. So that is 2/3 of pi, which means that there is a pi over 3. With all our cast diagrams, we're always interested in this. Now, so we ended up in this quadrant. What do we know about the sine values? They're positive, and it's equal to sine theta, and theta in this case is here. We're always interested in this acute angle. So if you were to type those into your calculator, you will see that they are the same. But the exact value of sine pi over 3 is root 3 over 2. Let's have a look at this a few more. So this time we're going to go to the cosine ratio, and this time we've gone over a whole, so we've got 1 1/6. So that's going to take us into this quadrant here. So that distance there is 7 pi over 6. What is the acute angle? This is the theta value we're interested in. If that's 1 1/6, that must just be pi over 6. So what do we know about the cosine values in this quadrant? Only tan is positive, so they must be minus. So this is the same as minus cos of theta, in this case, is that. Okay? I'm just doing exactly the same as this is here. So we had pi plus theta. So it's that last one there. It was 1 pi plus 1/6 of pi. So you could write it as this as well. This is a bit confusing. So you could say that is the same as cos of pi plus pi over 6. So that is your pi plus theta, and that's why it was equal to minus cos theta. Okay? Maybe just one more. So tan, the angles, so tan ratio, that is 1 3/4. So it's definitely over bigger than 1 1/2. So 1 3/4 takes us up into here. So we go all the way around. That is the same as 7 pi over 4. So what would this acute angle be? Well, 8 over 4 is 2 pi, so this must be pi over 4. Okay, so this is the acute angle here that we're looking at. So what do we know about the tan values here? Well, they're negative, so it's going to be minus tan. And what is our theta value? Here we're looking at 2 pi minus theta, and that is pi over 4. So you need to look up the exact value. I don't think I did that on the last slide because I started rabbiting on about why this all works. So tan pi over 4, you'll see in your book, is equal to 1. So it'll be minus 1. I'll just flick back to that one. cos pi over 6 is equal to root 3 over 2. So this one's equal to minus 3 over 2. Okay, so I do have, just one more. So this one's good because it's over a whole one. So we're actually gone all the way around because that would be 6 pi over 3. So this is actually 2 2/3. So we've ended up in here. Okay, so we've gone all the way around plus another 2/3 of pi. Now, what is this equal to? Well, sine is positive, and what is the acute angle that we're dealing with here? So this is, if you ignore the first part of this curve, this red bit here, that's 2/3 of pi. So this bit must be pi over 3. That's the 3, believe it or not. Okay. And so there you have it. And sine pi over 3, we just did that one earlier, is root 3 over 2. Just going to get rid of that because that makes no sense with that equal sign there. And there you go. So hopefully that makes perfect sense. It's just time for a bit of practice.